Alright, today's aim kipsters will be able to solve percent problems, same thing. So we're going to be looking at a do now here. So let's go ahead and start by looking at that. It says Corey has 80 model cars in his collection, which is 25% more. We see that 25% more, telling us this is going to be a percent change. More than what? More than Everett. So Everett is our whole. How many of the model cars does Everett have? So equals percent times whole. This is quantity. 25% more than Everett, telling Everett is going to be the whole. And that means Corey is going to be the quantity. So I can think about it that way. That's going to help me out. 25% more. If we're talking about the number of model cars, we're looking over here. It tells me how many total model cars. That means we're looking with final amounts. So I need a final percentage, which means my percentage here is going to be 25% more, or 125%. So looking at this, Corey has 80 is equal to, change this to a decimal, 1.25 times Everett, divided by 1.25. And when I do that math, I'm going to get 64 for Everett. All right, so let's move on and look at the rest of our work for today. All right, today's aim kipsters will be able to use quantity equals percent times whole to solve percent problems. So today we're just going to be looking again at just some more examples using our equation here. So we have 75% of the students in Jesse's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? So this is one where they're really just trying to throw us off. Looking at the 60 inches or taller, that's just a description of what we're looking for. The number 60 doesn't actually have anything to do with the math in this problem. As we work through our work today, please make sure that you are actually just going through and solving each problem. It's really just a practice day, and then you're checking back in. So if you've not already done so, please go ahead and solve this problem, then check back in to see if your solution is correct. So as we go through and we solve this one, it's 75% of the students in the class, so the whole is going to be the number of students in Jesse's class. So we're looking at quantity equals percent times whole. I know that there actually are 20 students in the class, so this is going to be 75% times the 20. So the number of students, or that part, is going to be the 0.75 times 20. And actually I can do this one in my head. 0.75 I know is 3/4. 3/4 of 20 is 15. Bobby wants to leave a tip for her waitress equal to 15% of her bill. Bobby's bill for lunch is $18. How much money represents 15% of the bill? So this is one where we're kind of talking about change, but we're looking for just the 15% of the bill. We're not looking for how much total they're going to end up leaving. So this is kind of like quantity equals percent times whole. Again, make sure that you've solved this on your own before you come and check in. But looking at this one, this is really just looking about the change in the price of the bill. So when I'm doing this one, I'm actually only going to be worried about finding the 15%, not 115%. The whole bill, as it is our start value, which is 18. And when I go through and I do this, I want to change it to a decimal. And we'll get, when we do this calculation, that our quantity of change is equal to $2.70. Looking at the next one, again, make sure that you've done it already. So looking at this, it expressed 9 hours as a percent of 3 days. So of the 3 days, that suggests that that's going to be my whole. Quantity is equal to percent times whole. So we're actually solving for the percent here. The whole is 3. The quantity is 9. Divided by 3. Tells me the percent is equal to 3, but it's not 3% because we see that this is 3 times greater. So this is way more than 100%. So we have to move the decimal 2 times. That's going to give me 300%. Coming down, it says Richard works from 11 a.m. to 3 a.m. His dinner break is 75% of the way through his work shift. What time is Richard's dinner break? All right, so this one we have to actually use this time information here to figure out how long he's working. And then once we figure out what 75% of the way through that is, then we can go ahead and get that started. So when we look at this, 11 a.m. to noon would be 1 hour. Noon to midnight would be another 12 hours. And midnight to 3 a.m. would be another 3 hours. So that's 13 plus 3 is 16 hours. Um, 75% of the way through the break. So the whole quantity is the 16 hours. Quantity equals percent times whole. 75% times the 16 gives us how far along his break was. That's 0.75 times 16. That's actually another one I can do in my head though, because we know 75% is 3/4. 3/4 of 16 is 12. So 12 hours through is when his break is, which is at what time? Well, 12 hours after 11 a.m. would actually be 11 p.m. All right, that's it for this page. We got some more practice over on the other side, so go ahead and flip on over to that as well. All right, at a playoff basketball game, there are 370 fans cheering for school A and 555 fans cheering for school B. Express the number of fans for school A as a percent of the number of fans for school B. So we have the percent of the fans for school B, so that's going to make school B be our whole. Quantity equals to percent times whole. Percent of fans for school B, that's our whole. School B is going to be our whole. And school B is 555. Our quantity is 370. Solve by 555. And that gives me that we have 0.666 repeating. Move the decimal 2 times. That's going to be 66.6 repeating percent. Now this asks me to flip it, the percent of the number of fans from school A. So again, as we set this one up, you should have set it up. Percent of what? That's going to tell me what my whole is. My whole is school A, which is 370. My quantity is going to be school B, 555. So this one's a little bit different. We end up with our numbers reversed in our fraction, which means this is going to end up being more than 100%. When I do this division, I'm going to get 1.5 is equal to the percent. So if I move the decimal one 2 times, that's going to give me 150%. Alright, this says what percent more fans were there for school B than for school A. So this is saying percent more. This is looking for the percentage of the change in the difference between the two sets of fans. So this is a comparison. It's looking for the percent more. So when we set this one up, quantity equals percent times whole. You definitely need to set this one up thinking about what is the percentage of change, so what's the quantity of change, and then what's the whole. Alright, percent more fans for school B than for school A. So we're comparing school B to school A, so our whole is going to be school A. Our quantity of change is going to be the 555 minus the 370, the difference between the two, which when I calculate that, I'm going to get 185. And when I get that, that's actually going to be the percentage change is equal to 50%. 0.50, move it 2 times, gives me 50%. It says a rectangle has a length of 8 centimeters and a width of 16 centimeters. Rectangle B has the same area as the first, but its length is 62.5% of the rectangle. Express the width of the rectangle B as a percent of rectangle A. What percent more or less is the width of the rectangle than the width of rectangle A? So what we have to do here is, this one's pretty complicated, and so I'm actually going to kind of sketch this one out. And this is one that I'm imagining you're checking in and you're needing a little bit of help. So at any point in time when you've got a little bit of information to help, you should move on. Alright, so 16, and the second rectangle, I don't really know anything except for I know that their areas are equal. So 8 times 16 is the area of this particular one. So I know they both have an area equal to 128. Alright, so it tells me it's 62.5% of the length of the first rectangle. So the quantity for rectangle B is going to be equal to the percentage of the whole of rectangle A. So we're looking at just the lengths here. It's only true about the length. So 65 or 62.5% of the length for rectangle A, length of 8, gives me this. So this is 0.625 times 8. And that's going to give me, no, not 6, that's going to give me 5. So I know the length is 5 here. The width I don't know, But I can set up my equation. Area is equal to length times width. And if I know the area is 128 and the length is 5, how can I find the width? Go ahead and figure that out on your own if you haven't already. I'm going to get 25.6. And it says, what percent more or less is the width of rectangle B? So we're comparing the quantity of change is equal to the percentage of change times the whole. Well, the whole is the original width, which is 16. The quantity of change, that's going to be 25.6 minus the 16. It's going to be 9.6. And so we're going to solve by dividing by 16. And this is going to give me 0.6 is equal to our percentage of change, which is 60%. Alright, looking at the next one, it's asking us for the percent of increase. One thing that you'll notice about this is you have different units, inches and feet. So you're going to have to put them both in the same units. I suggest turning the feet into inches before you can solve this problem. So make sure you've done that before you get started. As we get started with this problem, I see the 4 feet. I change that to 48 inches, 4 times 12. Quantity is equal to percent times whole. And again, I'm looking for just the percentage of increase, so percentage of change means I'm just looking for the quantity of the change. The quantity of the change, it changes from 40 to 48. So my change is 8 inches. And when we're talking about change, our whole is always the original. So we started at 40 inches. So it's grown and increased from 40. I divide by 40. That's going to give me 0.2 is equal to our percentage change, which move the decimal 2 times is 20%. And finally, Lauren must obtain a minimum number of signatures on a petition before it can be submitted. She was able to obtain 672%, which is 40% more than she needs. How many signatures does she need? All right, so this is a percentage change problem, but identify that we have the final amount. That's not a change in the amount. So what we're trying to find out is the original amount of signatures that she actually needed. Quantity is equal to percent times whole. We've got a final quantity of 672 is 40% more. So we've got a final quantity, which means we need a final percentage, 40% more, so that's 100% plus the 40% gives me 140% times the whole, which is what she originally needed. Move the decimal 1 2 times. This is 672 is equal to 1.4 times the whole. Gives me 480 for the original number of signatures she actually needed. Alright, flip on over to your lunchtime and get your work done.